Hi, everyone. So we are going to be starting the day one of the missing link, factoring completing the squares. Today, we're going to focus on the factoring, and the next time we're going to do completing the square. And our learning targets for today are factor out the GCF of polynomials, as well as factoring trinomials in general. We're going to be focusing on the quadratic ones as well. And remember, so if we're factoring them, then we're going to just change it from standard form to factored form. Okay, so I told you this unit we were going to do that, right? So for the do now and for your warm up, you're doing problems 1 through 4. Hopefully you can see them there. If you did not do them already, I would recommend that you try them out first. So press pause and then try them out and compare your answers. Again, you can do them with using the box method, or you can just distribute them like using the FOIL method. Either way is perfectly fine. All right. Just one quick note. Remember that if it's x plus 2 squared, that just means that, remember, squared means like x squared just means x times x. 3 squared means 3 times 3, which we know is 9. So same thing with this one, x plus 2 squared. Let me just write it here since it's a little bit hard to see over there. X plus 2 squared, what does that just mean? It just means x plus 2 times x plus 2. It's just that twice. All right, and then from here, now it looks exactly like 1 through 3, and we're just going to multiply that out. So again, for those guys who forgot, like, oh, I don't remember, this is what you would do. So these are both binomials. That's why you have 2 boxes going down and 2 boxes going across. And put the first box over here, second box x plus 2 over on top. Order does not matter, but I like to do the left one on the left and then the right one on the top. That's just what I like to do. And then remember how to get these guys right here. It's just like doing the multiplication tables. It's just x times x, which is x squared, right? We just talked about that right here. Look, yeah. And then 2 times x, which is 2x, and x times 2, which is also 2x. And then we have 2 times 2, which is 4. And then we're just going to combine like terms. So I like to start with the biggest exponent first. So it's x squared. And then the 2x plus the 2x, which is 4x, and then plus 4. And I, if you were there in class today, the person who was explaining this was like, well, they just went straight away to the answer because what they did was this. So the first one they did was, okay, this is x squared. And then in their brain, they're like, okay, I know that this x is going to multiply with this too. So that's 2x. And I know I'm going to have another one. So that's actually just 4x. And then 2 times 2 for the last term is 4. You could totally do that. If you can like think ahead and try to just do it in your brain like that, that's totally fine. That works. Happy days. But if not, don't feel bad, okay? Because this, again, you could do the area model way, which I call the box method, or you could do it the distributed way, you know, where we go x times x, x times 2, and then we take the 2 and we distribute that guy out. And then you write it all out and then combine like terms. That's totally fine. All right, we're moving on. Okay, so we're going to talk about the GCF. Now, what is the GCF? GCF is the greatest common factor. And we have to think to ourselves, okay, in all the terms, like let's say for letter A, the 4x and the 12, what factor do they have in common? And factor means we're multiplying, not adding. So we're not thinking about like, oh, 8 plus 4. We're not talking about that. We're multiplying. So I know that I can't pull out an x because x goes into both of them. X does not go into both of them. The 12 doesn't even have an x, right? So x is out of the window. And then I look at 4. I'm like, okay, does 4 go into 12? We're like, oh yeah, it does. And so this seemed to help. I'm going to just try it this way. Let's go with my green. So if we're going to factor out a 4, it's basically doing this. We're dividing both of these by 4. So here's my 4 on the outside, and what I'm going to do, what's left over is 4x divided by 4 is just x. All right, and 12 divided by 4, that's just 3. All right, so that's how we get 4 times x plus 3. And now if you were to multiply this back out again, so we're going to distribute the 4. So 4 times x is 4x plus 4 times 3, which is 12. Notice that this answer that we get is exactly the same as our original expression, right? So that's what we want. We know then we did it right, right? Always, like for me, what I like to do when I was in school, if I had enough time, was that if I had something like this, I was just supposed to factor out a GCF or just factor in general. I would multiply it back out and see if I get the original answer. And if that were true, then I'm like, okay, I'm 95% sure I got it right, unless I'm making mistakes on both of them, which I've seen. It's happened before. Like they missed a negative and then it like screwed everything up, but then they somehow missed it again and then it was the right answer. Like they got to the same answer. It's weird, but it doesn't happen very often. That's why I say 95% sure. If you look at these two terms right here, like what do they have in common? So this first term doesn't have any numbers in common, like it doesn't have a number, but it has two x's, right? X times x. And this one has one x. So how many x's can we pull out? Just the one. So that's we have one x here. And so again, we're dividing out that x. That's what factoring means. And so that what we have left is going to be x squared divided by x, which is just x. And 5x divided by x, it's just 5. All right. For me, how I like to think of it is I think of, okay, x times what number or what expression is going to give me, or variable, I guess, is going to give me an x squared. So I would be like, oh, it has to be an x because x times x is going to be x squared, right? So because I know that when I multiply it back out, it should give me the original expression, right? So and then I ask myself, well, x times what will give me a negative 5x? Like, oh, well, a negative 5. So either way you want to think about it, that's totally fine, okay? Everybody doesn't have to think the same way. There's a lot of ways to think about it, all right? And I would recommend that you try C, D, E, and F if you did not get to that yet. And if you notice right here, we did use that division from at this point, right? And for E, I just want to talk about that really quick. This one, somebody was quite clever. Was like, well, I could pull out a 2. If I pull out a 2, then this 11 would turn into a 5.5. But this, when we're talking about greatest common factor, 2 does not actually go into 11. So we're not gonna actually factor it that way. We're gonna just say it's not factorable. Not factorable. If when you take out a number that it gives you a fraction, that we're not counting that to be a thing. Okay, that's not factorable. Okie dokies. I would definitely try those out. Oh, also one last thing. I'll just do F right here, just in case, because I saw a lot of people struggle with this in last quarter. So if you look at all these three, right, there may be some they're like, oh, I got an X for both of these, but not for this 5. If that's true, that if the 5 doesn't have an X, you cannot pull out an X. The GCF is for all 3 terms, not just for part. Okay, so for all 3 terms. So while you might want to factor out an X, you can't because 5 doesn't have an X. And so, but what we can factor out is a 5 because 5 goes in all 3 of them. So we're going to go 5. And then I'm going to do this with a different color. So if we're pulling out a 5 right there, we're basically just dividing all of this guy by 5. And what do we have left in the inside? Well, this is going to be x squared. Negative 10x divided by 5 is negative 2x. And 5 divided by 5 is plus 1. All right. And remember, like I told you, if we were to multiply this all back out, if we were to distribute it all back out, it should give us an answer. And does it? Let's find out. So 5 times x squared is 5x squared. 5 times negative 2x is negative 10x. And 5 times 1 is plus 5. Notice right there, that's exactly the same as what we originally had. Yay, who knew? Right, but that's how you would figure that out. But normally from here, we can actually factor this more, and this is what we're going to talk about today. This is the highlight. Okay? And if you didn't understand this in class, then this is really we need to talk about this. So we'll come back to number 1 because I do want to relate it back to our what we're doing. So we're currently on page 157, all right? And we started just at number 4, and I'm going to teach it to you a little bit different than the way the book does, because I feel like the way the book does it, it's more confusing and it's not as efficient, okay? And so this is what we call the Criss-Cross method, all right? I'm modifying the original Criss-Cross method just because I think it makes more sense this way, at least when you're starting out. And then later on, if you want to go to the unmodified Criss-Cross version, go for it. Okay, so if you take a look here, if you remember back at the do now when we're multiplying things like this, right? We were just using the distributive way, or you could use the area method, and we would get x times x, which is x squared. And then we would get the 2x minus 4x minus 8, right? And so my question is, well, with this x squared, how do we get this x squared? You're like, well, we multiply the first two terms, right? The x times the x, right? And then how do we get this last one right here? We multiply with the last two guys. So the -4 times 2, that's how we got -8. Well, how do we get the middle part? We're like, well, the x times 2 and the -4 times x, that middle part, we added those guys up and then got that middle term. Like, okay, so this is what we're going to do when we're going to reverse engineer it. Okay, so I know how, so I set up, it's better if I just show you straight away. So let me show you in a new one. Okay, so here's my x squared minus 2x minus 8 instead of me talking about. So what we're going to do is we're going to write down the factors of x squared. Okay, because I know that my answer is going to look something like this. These first two terms are going to be x squared. So I'm going to go x times x. Okay, because I know that x squared is x times x. And how do I get 8 or -8? For me, I like to think of it without the negative first, and then I put in the negative later on, like I add it in when I'm refining my answer. But either way you think about it is fine. So 8, I know it's like 1 times 8, but remember it needs to add up to a -2, right? So let's pretend like I didn't know, and I was like, oh, well, 1 times 8 is 8. Okay, you're not wrong. Okay, so let's go. So now this is where the crisscross comes in. So we're going to multiply this x with the 1. And this is going to be x. And 1 times 8, which is 8x. And if I were to add or subtract these guys, would I get a -2? You were like, no, I would not get a -2. So we know, okay, this is not right. Okay, this can't be the right numbers. So then what is the other numbers? And you're like, Miss Lee, we already know it's 2 and 4, right? So here we had 2 and 4. I'm going to switch that up. I'm going to say 4 and 2. Does it make a difference? Let's find out. So x times 4 is 4. X times 2 is 2, right? 2 and 4. Could I get that? Which one has to be negative in order for me to add it up to -2x? So like it has to be -4, right? Because the bigger one has to be more negative. So this would equal up to a -2. So if we want this to be a -4x, then this has to be negative. That's how I like to do it. But if you want to do it from the beginning, go for it. It doesn't matter. So remember this number right here, what it adds up to has to equal this middle term, including that plus or minus. So whatever that is, if this is a minus, this got to be a minus. If this is a plus, this got to be a positive. Okay, and then we're going to go straight. Where's my mouse? Okay, there you are. So now this is not crisscross. They're going straight across. Boom. That's going to represent this guy right here. We're going to go straight across. Boom. That's going to be this guy right here. So we're going to go straight across, and what that is going to be x minus 4 is here, x plus 2, just like that. Now we factored it. And so again, like I said before, if you want to see, let's try using the box method, right? Because box method is fun. We're going to multiply it out and see if we do get the same answer. We should get x squared minus 2x minus 8. If we don't, we did it wrong. So here we go, x minus 4. Always get in the habit of writing this minus like this operation with the second term. This is going to be x plus 2. That'll just save you a lot of heartache. So a lot of people forget the negatives and then it gets messed up. So x times x is x squared. X times -4 is -4x. X times 2, 2x. -4 times 2 is -8. And if I combine like terms, I just get my x squared, -4x plus 2x. Do you see how these two, we add them just like how we did here? -2. This is going to be -8. All right, and yes, same thing. Happy days. So what I would have you guys do if you need more practice is try doing this again. Okay, use the same numbers. Just do it on a separate sheet of paper, blank. Don't look at this, right? So just look very hard and actually don't look very hard. Don't look at the numbers underneath the 24 or the 28. Although you probably just did that now since I talked about it. All right, and then and I would try it out again, right, and see if you can do it. And there are a lot of these other examples that we can do. So I'm leaving this here for you to see. I'm going to just do this. I'm going to do another example with with 3a. So x squared plus 17x plus 16. We're going to use the crisscross method way. Okay, and then I'm going to show you, like I promised, the box method way, reverse box method way. All right, so if you take a look at this, remember what times what multiplies to x squared? X times x. And what multiplies to 16 but adds up to 17? not 4 and 4, because 4 times 4 is 16. But when we add it or subtract it, we won't get 17. So I'm thinking 8 and 2, but it can't be 8 and 2 because 8 plus 2 is 10, right? And that's not going to give it to you. So I'm thinking, are you thinking what I'm thinking? 1 and 16. Let's try it. So now we're going to go crisscross. So 1 times, or x times 1 is x. 1 times 16 is 16x. And if I add them together, I do get 17x. Happy days, right? And they're both positive, so we're good to go. We don't even have to worry about it. So this is just going to be, remember, we're going straight across. So it's going to go straight across here. And I'm going to keep on doing this until people remember that this is a thing, because on the test, people will forget and go like, oh, x plus 1, and they'll do the crisscross here. No, there's only one crisscross. That's when we're multiplying. That's it. So x plus 1, and then x plus 16. And some of you guys may be like, Miss Lee, doesn't it give you the same thing anyways, even though you go crisscross? And I'm like, well, you're right. But if the number in front of x squared, if there's an actual number there, like a 3 or a 4 or a 10, you're screwed. It's going to be wrong. I'll show you in a bit. Okay. Sorry. Can I say that on YouTube? Sorry. So this is going to be your factored form. Okay. And let me show you on here. So we know that it's the same kind of process, but looks a little bit different. So if we know that, so always the first term right here, let me see if I could color coordinate these. So this I'll make yellow, and this is going to be yellow. So always the first term goes right here, and always the last term, come on, I'm going to make that purple. The last term is going to be right here. So I'm including the plus as well. Okay, now the question is, how do we get that middle term? The middle term is going to be, well, let's just make it pink. This, or no, that gets confusing with the other stuff. So we'll not do pink, we'll do green. Okay, so this plus 17 has to equal this plus this. Okay, so those two together add up to 17. So now you're going to have to ask yourself, well, how do we get x squared? Like, I know, x times x. So this is going to be x and x. And I'm going to have to ask myself, well, how do we get 16? And then, so I could say 4 and 4, right? But when I get this green guy, the green guys are my check. So I go 4 times x is 4x. And again, 4 times x is 4x. When that would be a total of 8x instead of 17x. So that's how we know that it's wrong. Okay. So it's definitely not 4. So we're going to have to ask ourselves as we go back, well, just like 2 and 8. So it's the same kind of question that you would ask here. And so remember, it was 16 and 1. So 1 times x is x, and x times 16 is 16x, right? And then so once you have that, we're like, okay, 16x plus x, that does give me 17x. Okay, and then we're going to just look at the sides, and the sides are what they would be. So the side is going to be, you see like how we said the x plus 1? This is x plus 1. And then the other side is going to be, come on, highlighter. Oh, I probably shouldn't have done it in that color. This is x and 16. So x plus 16 would be over here. Okay, so that the sides are what we would have here. Okay, and that's how you do it the box method way. But I'm just telling you what, if you have like other numbers here, like a 2 here, it's going to mess you up. And then what? But this is more the visual way. And if you like that way, totally go for it. All right, we'll just do the crisscross method a couple more times on this page. And if you want to practice first, I would press pause, try it, and then press play. All right. Your brain is not going to learn a thing by just watching people doing it. Okay. I can watch people play basketball all day long. It doesn't mean I know how to play it, even that good. Right. So just going to tell you that right now. So we got x squared, 6x minus 16. And again, what two factors multiply to x squared? Like, oh, x times x. That's the part easy. Right here, what about negative 16? It's got to add up to 6, but multiply. So I always think add or subtract to 6 and multiplies to 16. So I'm like, well, 4 and 4 don't work. It's either going to be 8 or 0. Like 4 plus 4 is 8, and 4 minus 4 is 0, so that doesn't work. So what about 2 and 8? Yes, I think that works. So 2 and 8. So x times 2 is 2x. x times 8 is 8x. And so I'm going to add this guy up, which one has to be, because I want it to be positive 6, so I do have to subtract them. So my negative 2x has to be, my 2x has to be negative, so that I end up getting a positive 6x. So remember, if I'm adding a negative here, add that negative right there. So, you know, when I multiplied, I would actually do get a negative out of that. And then we're going to go straight across. Boom, boom. Other one, boom, boom. And we're going to say x minus 2 times x plus 8. All right, yay. And one more. What about this guy right here? I'm going to put this down below because we need a little bit of room here. So I have x squared minus 6x minus 16. So what is that going to be? Press pause. So again, this is x times x, and this is going to be 8 and 2, probably again, because we want a difference of 6. And we know this time, the 6 has to be, the 8 has to be negative, because when we multiply it out, this is going to be negative 8x, and this is going to be 2x. So that this is going to be a negative 6x, which is what we want. Okay, so this is going to be boom right here, same, boom right here, the same. Happy days. And then again, we're going to go straight across. Straight across. Okay, that was kind of weird, but still straight across. So x minus 8, x plus 2, just like that. And now you know how to factor. Now the question is, why do we do that? Like, why are we learning how to factor? How's that related, right? So I'm going to go back, and we didn't do this in class, so hopefully you're watching the video. Thank you for the 2 people who are watching the video. All right, so we can do the same thing here, right? So we have y. We're going to write this in factor. So rewrite the original in factored form. So they would normally have you just graph this, and remember, you would have to remember the factored form, what it all means and all that kind of stuff. But we know how to do it now, right? So I'm going to just copy this down so I have a little bit more room. And we're going to be like, okay, I know how to do this. This is x and x. Again, feel free to pause. This is 2 and 8, because 2 times 8 is 16. And when I add 2 plus 8, that gives me 10, right? And this is going to be x times 2, which is 2x, x times 8, which is 8x. And yep, sure enough, it does give me 10x, just as I predicted. All right, and then we're going to write this going, so y is equal to x plus 2, going straight across, and x plus 8. All right, and if you remember anything about factored form, remember it would look something like this: a times x minus r1 at x minus r2. And remember, the r1 and the r2 were roots. They were our x and y, just our x-intercepts, right? So the r1 and r2 were our intercepts. If you look at right here, remember this is a plus, which means that this originally, because remember it's supposed to be a minus, it's originally supposed to be a negative 2, right? X minus a negative 8, right? So our roots should be at negative 2 and negative 8. If you look at right here, negative 2, negative 8. All right, and this is going to go on to what we learned later on. So this right here, I'll come back to this. Okay, I'm going to move on to the next part. And so on here, we did try out some different problems. This is on page is 158. All right, and see, do you see all the different trinomials that you can try and practice on? Remember, and this is a matching one, so it's not like this first expression goes with this first one. You kind of have to match it, just saying. So, but it looks like you are going to be using 1 and 4. So we're going to try this one right here, because we didn't do that. If you want to take a look at the other ones that we've done, you could totally try those out. Ooh, this should have been x squared. Nobody said anything in class. So we're going to try this guy right here, the third one. So 2x squared plus 5x minus 3. And you're like, oh no, I don't know how to deal with that, because we never done it. Use the exact same thing. And this is why I like this strategy so much, because a lot of other teachers, they teach this part separately, but it doesn't have to be separate. It's exactly the same skill. Now watch. So what 2 factors multiply to 2x squared? Or like, because I know normally we do like x times x, right? But what we're going to do here, well, we need a 2 somewhere. So honestly, it doesn't matter which one. just pick one. So we'll pick the top one this time because over here on our right, we actually did it on the bottom. And I want to show you that we could actually do it on the top too. It doesn't matter, like literally. Okay, and then we're going to ask the same question: what two numbers multiply to be a -3? Well, 1 and 3, right? And right now, we're not going to think about which order it should be in, okay? And so, actually, let me try the other way. I have a plan, guys. All right, so now we're going to do the crisscross, and this is where it gets more interesting. And notice I did not ask myself, oh, it multiplies to 3 and adds to 5. I can't do that because these numbers are going to be affected by this too, right? So x times 3 is 3x. And then this 2x times 1 is 2x. Now can I get it? Oh, I was doing it the other way around. I was trying to get it so it was wrong, but that I made it right. Ding dong. All right, and so the only problem is that one of these has to be, oh wait, nope, it's wrong. Because you're like, why? It adds up to 5x, and that's 5x. And you know why it's wrong? Because 3 times 1 is not -3. So we're like, okay, if one of these has to be negative, then we're never getting it a 5x. So I did do it right. Oh, phew. I psyched myself out. All right, so yeah, this actually doesn't work because this does not actually equal a -3. It actually equals a +3. So, okay, I can't use 1 and 3. So then you're like, well, what other numbers could we use? Because 3 is like a prime number and it's just 1 times 3, that's it. So what I'm going to tell you is, well, let's switch it. So we're going to, instead of doing 1 and 3, let's try, did I do 1 and 3? I don't remember which one I did. Oh yeah, so we're going to do 1 and 3. There we go. All right, so we're going to go x times 1 is x and 2x times 3 is 6x. Do you see how that number changed now? And now could I get it to be a 5? Which one has to be negative? You're like, okay, it has to be a +5. So that means it has to be a -x. So that means the 1 is negative. Okay, so this would give me a 5x. Oh, yay, happy days. And when I check my multiplication, 3 times -1 is -3. Phew. Okay, we're good to go. So now what we're going to do here, remember I told you to go across, but now do you see how it makes a difference? This makes a difference of you going across. So if you were not, oh, I should make this a darker color here. So if you're like, oh, 2x plus 3, that's wrong. That's not going to give you the right answer. Okay, that's going to give you something, it'll lead you astray. All right, so this is going to be 2x minus 1 in parentheses, and then x plus 3. You're like, Miss Lee, does it really make a difference? You're just going across. And so let me just show you. Let me answer that for you. So let's say you're like 2x plus 3, because you're like crisscross method, Miss Lee, x minus 1. Okay, and here's my proof to you. All right, so 2x times x is 2x squared. You're like, see, I'm fine. See, 2x squared, same thing. Okay, I'm like, okay, let's just wait. 2x times -1 is -2x. All right, and 3 times x is 3x. And 3 times -1 is -3. All right, well, we got the -3, we got the 2x squared, but what do we have on the inside? So 2x minus -2x plus 3x is going to be plus x minus 3. Do you see how that's a little bit different? A little bit, a lot of it, right? And if you're like, that's not that much different, don't build a bridge. We will not trust your calculations. You'll be like, it's just a 0. It's just a 5. Don't do that. Bridges will fall, buildings will fall. Don't work for them. Please don't. Save us all. All right, I'm just kidding. I'm sure you won't make that kind of mistake. So that's what that is. And so there is the, so it's, for me, it's a lot more interesting if we have a coefficient in front. It's not going to get too much more complicated than that. We might use other numbers like 3. If we're going to be really hard, it's going to be like 4, because if it's a 4, if this coefficient of 4, then it's like there's a couple that you could do 2 and 2, or you could do 4x and x. So there's like a lot of different combinations that you can use, right? So that gets a little bit more tricky. All right. So we're gonna move on down. All right. And we're going to 4.2, which is on page 161. Now, if you notice here, we're going to be using, so remember the last lesson, right? We talked about the property of equality, where we're just setting things equal to 0, and when it was equal to 0, and we're just solving for x, right? Like for example, 0 is equal to y is equal to x squared minus or plus, I don't know why I said minus, plus 1. Oh, actually, we wouldn't get an answer that way. I should have, my mouth knew what I was doing. Minus 9, let's just say, right? So if we have something like this, if we want to find the roots, where are the roots? The roots are on the x-axis, right? Which means what is the value of y? It's always going to be 0, right? So just like how we find the y-intercept, to find the y-intercept, we set x equal to 0. To find the x-intercept, we set y equal to 0. Okay, it's fair that way. So we're going to set this equal to 0. So 0 is equal to x squared minus 9. And now we can just solve for x, right? This is what we did last time. And so we go like, oh, just plus 9, and 9 is equal to x squared, and I ran out of room. And so I'm just going to rewrite that like this. How do you get rid of that square? You're like, square root. Yeah, that dividey thingy. Yeah, the square root. And this is going to be x is equal to, remember whenever we're adding the square root, we're adding the plus or minus, because there are 2 different ways to get 9. 3 times 3 and negative 3 times 3. There's 2 different ways. So we have to do that. Remember, this is called the plus or minus. And I'm not saying that like it's a choice. It's just saying it's plus and it's minus. But I guess plus or minus just has a better tone to it. I don't know. So we'll go with that. So that's like how we solve it. And so we know that our x-intercepts are going to be at 3 and at negative 3. So to bring it back to the graph, right? So that would be my x-intercepts. And then the graph would look probably like this. Oh, wait, where the vertex is on the y-axis at negative 9, because, you know, y-intercept, negative 9. But anyways, but that's what it should look like. We're going to do the same thing with these guys. So if we have this quadratic equation right here like this, x squared minus 4x equals negative 3. What we're trying to do is we're going to solve for x, which means I know it says to calculate the roots, right? Which means we got to set this thing equal to 0, right? So, oh, we did it right over here where we had some more room. I like to do it by myself. So I copied down the problem, and the first thing to do is set it equal to 0, right? And because, yeah, we want that y equal to 0. And so we're going to add 3 to both sides to give her that minus 3. And so now we have it equal to 0. Because ultimately what we want to do is a 0 product property. If you saw yesterday's video, you would know that. But if not, that's okay. You know it now. Well, we'll talk more about that in a bit. But once we have x squared minus 4x plus 3. We're like, let's see if we could factor it. Can we get it in factored form? Because if we get it in factored form, we know the roots, right? Because like that's what factored form tells us. And so we go x and x, and we thought of 3. To get 3 is 1 times 3, right? But remember, we want to get it to add to negative 4. Well, how are we going to do that? They both have to be negative, okay? Because the only way that this number multiplies to be a positive, but you get, you have to add them, and to get negatives, that's the only way you can do that if they're both negative, all right? And so we got a negative x minus 1 times x minus 3. And if you notice right here, so the big key here, the big takeaway is that it's equal to 0. And this is where the 0 product property comes in. You see this guy right here, 0 product property. I would highlight that, which states that if the two products, if the products of 2 or more factors is equal to 0, then at least one factor must be equal to 0, right? So in other words, either x minus 1, because that's a factor, because this is actually just one number, right? We just don't know what x is. And if we knew what x is, we would subtract 1 from it, and that would be the number, right? So x, either this is going to equal 0, or this guy right here is going to equal 0, x minus 3. Okay, so we're going to do both of those, because either way, we'd still get an answer. So here's my x minus 1, and here's my x minus 3. And we're going to just set those equal, because we're like, well, what would x have to be so that it would equal 0, right? And we figured out that x would have to be, so this comes back to our Algebra 1 or maybe our middle school days, like x minus 1 equals 0. What could x be? Like 1, because 1 minus 1 is 0. So here's x is equal to 1. Do you have to show this work? Not in Algebra 2. I'm going to assume that you already know that's +1 on both sides. Or you could even think it in your brain. You're like, oh, what -1 is equal to 0? Well, it's going to be 1. Now, what -3 is equal to 0? Well, it has to be 3. Right? But if you want to show your work, please do. I would love that too. And so we're going to combine that. Goes x is equal to 1, 1, 3. Please do not put commas in. Like, don't do this. That's bad. I've seen some people do that. That just means it's a point. This is not a point. This is 2 values here, right? So we're saying that the x-intercepts are going to be here at 1 and 3. Okay, we're not saying that this is the point 1, 3, because 1, 3 is like up here. It's that point right there, and that's not what we're saying. That's bad days. That's not even on the x-axis. It's not an x-intercept. Okay, so that's what that's going to look like, just like that. So let's try this. Okay, so if you take a look at Jana, and I said I would go over this. Okay, if you notice the thumbs down, they did something wrong. So Jana, what did Jana do wrong? She's like, okay, so it looks like she factored out an x, which looks fine, right? Because x times x is x squared and x times 6 is 6x. So, and they had an x in common. So, okay, that sounds good. And then she's now setting everything equal to 7. So x is equal to 7 and x plus 6 is equal to 7. That's where she went wrong. I hope that triggered a memory. I'm like, you're like, wait a minute, that doesn't look right, right? Because what is this called? The 0 product property, not the 7 product property, right? Only 0 has this special property. 0 is very special. Okay, so this, bad days, they get a thumbs down. Okay. All right, so how would you solve this? You got to get rid of that 7. Now you make it equal to 0. And how do we do that? To subtract it, right? So it should just be x squared plus 6x minus 7 is equal to 0. And now since it's equal to 0, now if we could factor the left-hand side, then we could use a 0 product property and life will be good. All right, so we're going to be like, okay, this is x and x. Again, press pause if you, because you need to try it out. Give your brain a chance. X times 7 is 7x. X times 1 is x. And we know one of these has to be negative because we want it to get, it needs to multiply to be a -7. And plus it has to be a positive 6x. So the negative is right there. So then it's going to go, we're going to go straight across. X plus 7 times x minus 1 is equal to 0. Now we know that x plus 7 has to equal 0 or x minus 1 has to equal 0. Either way you will, if one of those is equal to 0, we're going to get an answer. I'll just put it over here on the left. So we're going to set them equal to 0. All right, so how do we solve for this guy? Like subtract 7 on both sides and we get x equal to -7. Add 1 on both sides and we get x equal to 1. So our x is equal to 1 and -7. So those are the 2 possibilities that could be. So if I were to plug this back in, right, it should give me a 7. So it says because it equals 7, I like to put it back in the original. So I go 1 squared plus 6 times 1 is equal to 7. I'm putting a question mark over there because I don't know. So 1 squared is 1 plus 6. And yep, that does equal 7. See, told you. And what about, and you're like, well, what about the -7? That doesn't look like it's going to work. So I'm going to go like this. I'm going to I'll put it in green. So we'll go -7. And remember your parentheses because the negative is included with that square. Plus 6 times 7. Oh, -7. And does that equal 7? That's going to be the question. So -7 times -7 is positive 49. And plus 6 times -7 is -42. Does that equal 7? Yeah, 49 minus 42, 100%. Okay, and so those are the only 2 answers that will work. Any other answer? It's not going to work, or else we would have found it. Okay, and same thing with Reese. Reese looks like she did the same thing too. Right here, she did not set that equal to 0, and she already just factored stuff. It can't do that. That's again bad days. All right. So let's try this out. If you need some more practice on it, this is a good time to practice. So we're going to go x squared plus 5x plus 6 is equal to 6. So we're going to subtract out the 6. We're like, oh, wait. Then that means we just get x squared plus 5x. That's just 0 is equal to 0. Is that a thing? Like I can't factor now like how I did here because I don't have anything. So what you can do is you can do the GCF, right? So, well, what goes into both of these guys? Well, x and we get x plus 5 left is equal to 0. Like, can we still do the zero product property? And I'd be like, well, are you multiplying two numbers? And you're like, yeah, we have x and the x plus 5. Those are our two factors. Like, then set them equal to 0. So we got x equals to 0 and x plus 5 is equal to 0. So how do I solve x equal to 0? It's already solved for it. You don't have to do anything else. And this one is just going to be subtract 5 on both sides. So x is equal to -5. So what are your two answers? 0 and -5. Yay. Okay, so this is more practice for you guys. I'm just going to give you guys the answer so that you can see. Later on, if you get a little bit more versed in factoring, you actually don't have to, the shortcut way is you don't have to, for the crisscross method originally, before I modified it, you don't put in the x's. You just put in the coefficient, right? And just go 1 and 1. And I'm thinking, what two numbers multiply to 12 and give me an 8? I'm like 2 and 6, and they both have to be negative. Right, and then you just go -2, this is -6, that's -8. Oh, yep, that's perfect. And I'm just looking at the coefficient. So here I've eliminated all the x's. And so this just makes it for quicker work. Do you have to do it this way? No. But the more you practice these, you will probably eventually get to this just because it's just faster and less work. And you know what all the stuff means. And then when we go across, it's just going to be x minus 2. And x minus 6 going straight across. Remember, just like how before. And remember the x, remember this was the 1 is the coefficient of the x, right? We just took out the x's for now. And that's equal to 0. So our x is going to equal 2 and 6. So I'm going to just give you the answer so you can practice. I'll just do it the way we've been doing it, just so that you can refer back to it and see if you get what I get. 6 and 4, 8 and 3, 8 and 3. So this is going to be -8x. This is going to be 3x, -5x. So we're going to get x minus 8, x plus 3. So x equal to 8 and -3. And this is going to be 25, no, not 25 and 3. 15 and something. 3 and 25. This is 5 and 5, right? 15 and 5. Okay, 15 and 5, I could do that. 15 and 5. And the 15 has to be positive. So we got 15x, and this is going to be -5x plus 10x. Happy days. So we get x plus 15, x minus 5 is equal to 0, x is equal to 5 and -10, 15. Totally meant that. All right, and then this last one, we're like, ooh, remember we didn't have the other two, and what did we do? Yeah, factored out the x. So x minus 11 is equal to 0. So literally, it's just x equal to 0 and 11. Okay, no, and guys, please make sure, or peoples, not all of you guys are guys, I suppose, right? But please make sure, like on a test, you do show me that you're setting these equal to 0. Okay, that I'm looking for that. Oh, more practice. I'll just quickly do these. Actually, I'm going to press pause. I'm going to do them, and then you can just check your answers, okay? I think that might be better. Or maybe not. All right, I'm just going to, because factoring is one of those things that is really, really important. So the more you practice it, the better. But if you want to skip forward through this because you're like, oh, Miss Larry, I think I got it now, then no worries. My feelings will not be hurt. So this is going to be 8x plus 7. And the reason why I'm doing this is because remember, we want it to equal 0. Very important. Don't be, as my kids, don't be a noob. Make sure that it equals to 0. And then once you have that, now we can use the zero product property, right? Well, once we factor. So here we go. We got x and x, and this is going to be 7 and 1. And this is going to be 7x. This is going to be x. So we get 8x. Yay, happy days. It's going to be x plus 7, x plus 1. And then this is going to just be x equal to -7 and -1. I like to box my answers. Ooh, what in the world? Let's take everything to one side because the right-hand side is all full. So I'm just going to, all full. It's awful. All right, and I'm also going to add the 81. I'm just going to do it all at once. I'm going to go plus 81. All right, and what do I have? I have x squared. I am not adding the x squared with the 81 because that doesn't make any sense. So that's a perfect square. I'm not a perfect square. That's a variable. They're not like terms. All right, so x squared and these two are the same. So this is going to be minus 18x, and this is going to be plus 81. How do I do that? Never done something so big. So let's try it again. So this is x and x. Oh, what two numbers multiply to 81 and add up to 18? Or add or subtract to 18? It's got to be 9 and 9. Happy days. And they both have to be negative, right? Because it adds up to a negative 18, right? So again, just to check, so this is negative 9x. This is also going to be negative 9x. So that's going to be negative 18x. Correct. All right, so it's going to be x minus 9 times x minus 9 is equal to 0. Remember, we set it equal to 0, so we got our equation down. And you're like, oh, it's the same thing. So literally, you could solve this actually two different ways. X equals to 9. There we go. Remember, it's just x minus 9 is equal to 0, and you just do that 2 times. And you're like, oh, it's just 9. So this is, remember what we call, what do we call it when it happens 2 times? We call this a double root. Okay, double root. All right. If some of you guys may have noticed, well, isn't that just the same as saying this x minus 9 squared is equal to 0? And you're like, you're not wrong. Yeah, that is totally the same. Could we solve it now just by solving for x? Like, yeah, we totally can do that. We can square root both sides first, since the exponent is on the outside. And we get, what color was I using? X minus 9 equals to plus or minus the square root of 0. Well, what's the square root of 0? 0. So I should technically just take out that square root. It's just 0. Okay. And then now we're going to add 9 to both sides. And we get x is equal to 9 plus or minus 0. So it's 9 plus 0 and 9 minus 0. 2 different times 9 comes out, but it's still 9, right? So x is just equal to 9. And later on, we'll add more things detailed to that. But for now, this is just all we're going to write. Okie dokies. But probably instead of doing it this way, it's just much easier to just set them equal to 0. 0 product property, way easier. Some of you guys are like, I don't know, I'm just gonna skip that one. You want me to show you a cheat to the system? Get rid of fractions altogether. Basically, you're just going to take the, what number does 3 and 6 both go into? Because I'm getting those from their denominators, because if only those denominators were gone, like I would be happy, right? So what we're gonna do is, well, I know that 6 goes in, 3 and 6 both go into 6, right? So I'm going to just multiply everything by 6. Okay, so the left-hand side and the right-hand side by 6. That's why the parentheses around everything, right? So 6 times, I'll just rewrite that again. I'm going to do it the fast version, and I'll do it the slow version way. Okay, so I'm going to distribute this, and I'm going to go, I like to divide first. So 6 divided by 3 is 2, and then 2 times 2 is 4. So there's 4x squared. And 6 divided by 6 is 1. And 1 times 5 is 5. So it's minus 5x is equal to 6 times 0 is 0. See how 0 is so awesome? And now we can just do what we would normally do and just solve for this, right? And see how we have no more no more, what is it called? No more fractions. And now it just looks like normal. So the slow version of that, like this is like the steps spelled out for you. So this right here, 6 times 2/3. So if you go 6 times 2/3 x, right? So remember this like 6 over 1. And so I am going, you can multiply it together, right? So 6 times 2 is 12. So it'd be 12 over 3x. Oops, squared. Well, what's 12 over 3? 4. That's how we get the 4. And you're like, well, Miss Lee, didn't you do something about divide? I'm like, yeah. And if we look at the 6 and the 3, remember like cross canceling, right? What goes into both 6 and 3? You're like, well, 3 goes into them 2 times, right? Or remember, this is just like this is just divide. Fractions are just division. That's all it is, right? And so then we take this 2, and 2 times 2 is 4. So either way you want to think about that, it's completely fine. Either way is fine. All right. And then we do the same thing with this one. And here I know that the 6's cancel out, right? And then all I have left is the 5. For me, I like to do division first, because I would rather not have to calculate a thing. Use a calculator, it's just too much work. All right, and then GCF. X is the same for both, and because we only have two terms, and all we have left is 4x minus 5 is equal to 0. Again, we're going to use the zero product property. It's going to be x is equal to 0, and 4x minus 5 is equal to 0. And you're like, ooh, this looks a little bit different, a little bit harder. This is like level 2, right? So this is, remember, we're just adding 5 to both sides. And then what do we get? 4x is equal to 5. And then just divide both sides by 4, so 5 over 4. So our answer is going to be x is equal to 0 and 5/4. Just like that. All right, last one. Just do that one really quick. 4, 3 doesn't work because 4 times 3, but that's not going to give me a 10. Then what about like 6 times 2? No, that can, highest number is an 8. 12 times 1. Oh, not factorable. What do we do when it's not factorable? Uh-oh. We'll find out. We learn later on, like tomorrow, or not tomorrow, next lesson. Yeah, that's the thing. All right, we're just gonna stop right there. We had just talked about this. This was just 2 different ways to solve the exact same problem. This Dion uses just solve for x, right? And Kayla recognizes, oh, this is a difference of 2 squares. And then use the zero product property and then solve for x. Either way, you're going to get the same answer. All right, I will see you when I see you. Good job for coming here.